Here we utilize two properties of rhombus so that we can write an expression for the side AD. One of the property is the diagonals of the rhombus bisect each other at right angles. And this means the angle between the two diagonals is equal to 90 degree. So I'm going to put this little square symbol to indicate that the angle between the diagonal BD and AC is equal to 90 degree. So this is one of the property we utilize, and this means now if we mark this vertex or the point where the diagonals meet as O, we consider the triangle OBC, which in fact is a right triangle. We can apply the Pythagorean property, and this states that the sum of the squares of the two sides is equal to the square of the hypotenuse. So we have OC as one of the side and OB as another side of the triangle, and BC is the hypotenuse of the triangle. So these two are sides and BC is the hypotenuse of the triangle OBC. So here we apply the Pythagorean property, which states that OC square plus OB square equal to hypotenuse square, that is BC square. So now we can plug in the values of OC and OB. We know that the OC is equal to 2n plus 5. So I put 2n plus 5 for OC, quantity square, plus OB is given as 4n minus 3. So I substitute 4n minus 3 for OB, and this is equal to BC square. So first let me determine the BC from this. So I have to take the square root on both sides, which results in 2n plus 5 quantity square plus 4n minus 3 quantity square. This is under the root equal to BC. Now we know the from the rhombus, the another property that we use to solve for AD is the sides are congruent. All the four sides are congruent in a rhombus. And this means we can say that side BC is congruent to side AD. So BC is congruent to AD. So therefore, we already found out the value of BC. So we can write down the AD as the same expression, that is square root of 2n plus 5 quantity square plus 4n minus 3 quantity square. So this is the expression to determine AD in terms of n.